In the previous videos, I worked in 1D and 2D, that being perimeter and area. And in this video, we're going to be focusing on 3D. So we're going to be taking a new aspect to this. This is in two segments, just like the area videos, and we're going to be looking at volume of basic shapes and volume of more complex shapes. So to start, I just want to mention it's important to take notes, and I recommend taking notes of the volumetric equations for the shapes that I will be discussing, because there's a lot of shapes and this is a fairly long video. So to start, let's go over a little bit of review here. So when we were in elementary school, we typically would be asked to find the volume of rectangular prisms or cubes. And we know that volume is equal to the length times the width times the height. So this could be the length, this could be the width, and this could be the height. And then if you had a cube, it might look a bit different. So if you had a cube here, there's two things you can really do with a cube. So volume could be two things. So you could still apply the volume is equal to length times width times height equation, but the more simplistic route is just volume is equal to the side length cubed. And this is because, and you might have seen either or equation, and they're both right, you're going to yield the same answer. So when you have a cube, all side lengths are equal length. So this is equal to this, and this is equal to that. So when you're working in 3 dimensions, like this, if we're just going to take out and crop out just this little section here, we have the x, and then you can technically say the y, and then the z here. And it's just, since they're all the same length, it's just s, and s, so it's s times s times s, or s cubed. So that's kind of why you might see s cubed, volume of a cube is equal to s cubed. And we obviously know how to solve for these equations, or at least I hope. So now we're going to be focusing on some more realistic shapes. Some other shapes that you will also see in the real world here. So we're going to look at spheres for a second. So spheres. So the equation for a sphere, and I'm just going to draw like a circle here because I'm not good at drawing spheres. But let's give it some like shading here. So here's our sphere. The equation for finding the volume of a sphere can come in two formats. So you can do 4 over 3, so 4/3, times pi, that's a bad pi, times pi r cubed. This is one way to see the equation. So you could see the equation like this, or you could see the equation like this. So you can see 4, let me do that in black actually, 4 pi r cubed divided by 3. And like the cube equation, there's 2 equations, but either one of them, there's not one correct answer. They're both the same. You're going to yield the same volumetric values, just written a bit differently. If you're using a calculator, sometimes it's easier to just do 4 pi r cubed divided by 3, and just some people prefer 4 over 3 pi r cubed. It's kind of just a personal preference, or whichever one you remember better. They're going to yield the same answer. Now if we are going to look at cones, so let's look at cones. We're going to look at cones, and actually I could probably write that a bit better. So cones. So cones, we obviously know. We all know what a cone is, I hope. So a cone has a circular base. Kind of looks like a birthday party hat, something you'd wear at your friend's birthday. And it looks like this. So that's going to be our center point of the base. And you're probably wondering, how do we find the volume of a cone? Well, we know if we know how to find the volume of a cylinder, which looks a little something like this. The volume of a cylinder this is our cylinder. It's basically just a giant bunch of circles stacked on top of each other, like a cup. So the volume of a cylinder, so if we have our cylinder, the volume is equal to the area of a circle. So the area of a circle is pi r squared. Probably do that a bit better. Pi r squared times the height. So this little red, it's not the right color. So this red shaded region is going to be our area of the circle. So pi r squared. And then we're going to multiply by the height, which we're going to, I don't know, let's do blue. The height, which is this little line here that I just kind of shaded in, the height multiplied by the height. Now, with a cylinder, you may realize if you were to take a cylinder and you were to lay it flat on the ground and you were to look at it precisely at, like, the side, like, you would get this, you would be viewing basically a triangle. And this actually relates to the volumetric equation. So if you were to look at, this is kind of like if you were to look at a cone from the side, or if you were to get a cross section, and that's actually next. And that will be discussed further later. But if you look at a cone from the side, you kind of see a triangle. So for a cone, the volume is equal to 1/3, and this is because if we get our little piece here, this piece, this is 1/3, this red shaded region that I'm coloring right now, that is 1/3 of this entire rectangle that I drew. And if I drew it properly and proportionally, so is this center rectangle, or the side view of the cone, and so is this. So it's split into thirds. So you're going to get 1/3, and then multiplied by the cone equation. So 1/3 pi r squared times the height, just like that. And that's how you get the volume of a cone. So I want to sort this out for you guys so you guys can see this a bit better. So everything's nice and organized here. So now that we looked at spheres, cones, and cylinders, let's look at pyramids. So there's pyramids come in all sorts of, there's all sorts of different types of pyramids. So if we look at pyramids. So if we look at pyramids, we typically, when we think of a pyramid, we typically think of something like the Great Pyramid of Giza. And let me draw this a bit better. Probably better that if I draw it like this. I don't know how well this pyramid's gonna come out here. But we typically think of a pyramid like the Great Pyramid of Giza. Like those of the ancient Egyptians, right? A square base and it's just triangular on all sides and it's at a slant. So how do we find the volume of this pyramid? Well, pyramids don't just have square bases. You can have triangular pyramids, and what that will look at, this might not turn out super good, but a triangular pyramid is where the base of your pyramid is a triangle. Can't really tell that's a triangular pyramid, but it's basically just a standard pyramid you may think of, just with a triangle base. And then there's also pentagonal, hexagonal, and octagonal pyramids, and pyramids with just basically any type of polygon as the base. But we typically think of square or triangular pyramids. So the general equation for any pyramid typically is just 1/3 multiplied by the area of the base, so the area of the base multiplied by the entire height of the pyramid. So if we were to look at a standard pyramid, so here, let me make sure and highlight that this is the general equation for a pyramid. So if we were to look at a pyramid with a square base, we could say 1/3, let me change the color of that. We could say 1/3 multiplied by the length times the width, since we're dealing with 2D, multiplied by the height. So let's take this pyramid and let's drag this down here. And let's say that this is the length, this is the width, and then this right here, this is the height. And this is what it's referring to by height. It goes from the top right here. So this point of your pyramid, I believe, is called the apex of the pyramid. And typically, you were supposed to go from the apex of your pyramid all the way to the base, and that's the height. It's not this slanted line here. That's not the height of the pyramid. It's typically from the center point all the way to the tippy top, the point or the peak of the pyramid you're dealing with. And that applies to all pyramids. So in this case, if this was, 3 and this was 2 and the height was, 6, we would say 1/3 multiplied by 3 times 2 times 6. So we can say 1/3 times, and then 6 times 6 is 36. And then we would just get 1/3 of 36, and that is about 12. That's 12, I believe. So the volume of this pyramid would be 12 whatever units you are, cubic centimeters, cubic inches, which brings another important point, that when you're dealing with 3D, whether it's a sphere, a cone, a cylinder, a pyramid, a torus, anything that you're dealing with, your units are always going to be cubed. Cubed centimeters, cubic inches, cubic yards, because you're dealing in 3D. Let's go over some pentagonal and hexagonal pyramids before we move on. So if we look at a pentagonal, and I don't really know how I'm going to do this, but if we look at like a pentagonal pyramid here, it would look a little something like this. So we would have this triangular point, we would have a point here, we would have a point here, we'd have a point here, and we'd have, that was not good, we would have a point here. So this would be our like pentagonal pyramid. We would have a total of 6 faces, so 1, 2, 3, 4, 5, 6, including the bottom. And the volumetric equation would look like this. So 1/3 multiplied by the area of a pentagonal base. So this, in this case, would be 1/4 multiplied by the square root of 5 times 5 plus 2 root 5 times the side length squared, and then multiplied by the height. It is this very long equation, and let me just kind of show you what this all means, or what this would look like. So this red shaded region that I'm covering in, this is the area of the pentagonal base, the base that makes up this pyramid. That would look like this section. So this is to find the area of the pentagonal base. And then if we were to look at the height of the pyramid would be from this green point in the center up to the apex here, which is the peak or the point of our pyramid, and it would look a little something like this. So this would be the height, right? That's the height. And then the 1/3 comes just like from the cone idea with the rectangle and looking at it from the side. That's where the 1/3 comes in. Just because if you look at the side, you get 1/3 of a rectangle if you were to draw a rectangle like that around it. And this also applies, so you're going to do 1/3 multiplied by the area of the base of your pyramid, whether it's a triangular pyramid, a basic square or rectangular pyramid, or if you're dealing with a pentagonal, octagonal, hexagonal, septagonal, any base pyramid, any pyramid, it's always going to be 1/3 multiplied by the area of the base multiplied by the height. And that is the volume of just basic shapes as spheres, cones, cylinders, and pyramids. In the next video, I will be going over volume of more complex shapes.